Hello, hi everyone. Welcome to the Stone the Brand. This is our Shiva sir. Today topic is magnetic effects of electric current. So today topic is magnetic effects of electric current. So what is the magnetic effects of electric current? So when current is passing through the conductor behaves as or it produce magnetic field. It produce magnetic field. Okay. So it acts, it shows the magnetic behavior. So that is the current carrying conductor placed in the external magnetic field. External magnetic field. It behaves as a magnet. Okay. So let's start. Oh my god. Let's start the topic. Magnetic effects of electric current. Magnetic effects of electric current. Magnetic effects of electric current. Okay. So when the current is passing through the conductor, it acts as a magnet, or it shows the magnetic behavior. Okay, so that is the magnetic effects of electric current. So now we will discuss about magnetic properties. First of all, we have to discuss about magnetic properties. If you suspend freely any magnet, it always shows north and south direction. There are two types of magnets. So one is artificial magnet, another one is natural magnet. Natural magnets are which occurs from the earth. Magnetite is a natural magnet. Okay, or lodestone. So is the natural magnet. Coming to the artificial magnets, according to our requirements. So according to the industrial purpose, so magnets are made. Okay, humans are made those magnets. Those are called artificial magnets or man-made magnets. Okay, so like U-shaped magnet, bar magnet, dumbbell-shaped magnet, horseshoe magnet, like different kinds are there, different types are there. Understood? So different types. So among that one, today we are going to discuss about bar magnet. So about bar magnet, we'll discuss all the points. So how the magnetic field will be there, what are the properties of magnetic field lines, okay, around the bar magnet, what are the magnetic field lines, in which direction the magnetic field will be there around the magnet, in which direction the magnetic field will be there. Okay, so what are the properties of the magnetic field lines? So everything we'll discuss now, right? So you can observe here. So I'm taking the bar magnet. This is a bar magnet, north and south. Okay, this is north and this one is south. North and south. Okay, so magnetic field will be outside of the bar magnet is north to south. Inside of the bar magnet is south to north. Okay, so if you consider outside of the bar magnet, the magnetic field is north to south. Inside of the bar magnet is magnetic field is south to north. Outside is north to south. Inside is inside. If you are taking inside, so it will be south to north. Okay, so I hope it is very clear. So you can observe like this. You can observe. Understood? So here outside it is moving. The magnetic field is moving away and towards the south pole it reaching. Understood? So this what is one? Magnetic field around the bar magnet. Here we need to discuss about first one is magnetic field magnetic field. First one is magnetic field. First one is magnetic field. Second one is magnetic field lines. Magnetic field lines. Magnetic field lines. Okay, so magnetic field lines. So first one is about magnetic field. About magnetic field. Magnetic field. The region around the magnet in which, so the region around the magnet in which magnetic force exert. So if I'm taking this a magnet, this a magnet. So around this point only, around until certain distance only, the magnet will attract the another magnet. This magnet will attract another magnet. If you go away from this, away from the field, so this magnet will not impact the magnetic material. So if you are taking this a magnet, so until certain region only it will attract. Until certain region only it will attract. Beyond the field, so if you cross the field, if you go away from the magnet, so beyond the magnetic field, then this magnet will not interact, this magnet will not impact, this magnet will not attract, this magnet has no impact on the materials which is moving away from the magnetic field. Okay, so within the field itself, within the region or within the field, the magnet will attract the magnetic materials. Okay, the region or the space, around the magnet in which magnetic force exert is called magnetic field. Okay, so this is about magnetic field. And coming to the next one, magnetic field lines. What are the magnetic field lines? So the field will be in the form of field lines. Okay, so how the field lines will be there? Okay, so outside of the bar magnet, the magnetic field lines are from north to south. Inside of the bar magnet, the magnetic field lines are south to north. Okay, so the region around the magnet in which magnetic force exert is called magnetic field. The region around the magnet in which the magnet will exert the magnetic force. Okay, so that is called a magnetic field. And the magnetic field, so I said a region. So in that, magnetic field will be in the form of field lines. So these are the lines. These are the field lines. Okay. So outside of the bar magnet, my magnetic field will be north to south. Inside of the bar magnet, the magnetic field lines are south to north. Okay. So that is the first point. So magnetic field. And the next one, magnetic field lines. Magnetic field lines are closed loops. Magnetic field lines are closed loops. Okay, emerge out from north, merge at south. These field lines never intersect. Okay, these field lines never intersect. If it is intersect, so what happens? Actually, compass is nothing but a small magnetic needle is present inside of it. Okay. Okay, so I am taking, this is the north and south. North and south and east and west. North and south and east and west. Okay. So thank you so much for supporting. Thank you so much supporting the channel. So please do like, share and subscribe to Student the Brand and share to everyone. Okay, as much as possible, as soon as possible, because now high time for preparation. Okay, come to the point. Okay, come to the point. Now you can see magnetic field lines are closed loops. They will not intersect. So they will never intersect. See, normally, so if I want to find out the magnetic field direction, if I want to find out the magnetic field direction, very good, ma. So here at this point, if you draw the tangent at that point, so along the direction you can observe, along this direction you can observe, along this direction you can observe, along this direction you can observe. So at each and every point we can identify the magnetic field by drawing the tangent to the magnetic field lines. Okay, magnetic field lines. If you draw the tangent, tangent is nothing but the line touches the curve at one point. At that particular direction, we can identify the magnetic field by drawing the tangent. So if these field lines intersect, so like this, okay. So definitely I will explain, I will tell one day. So this one you can see. So this is the direction. This is also direction. So compass should show at a time two directions. It is not at all possible. So compass should show at a time two directions. It is not possible, right? Definitely it is not possible. So compass will show at a time only one direction. Compass will show at a time only one direction. If these field lines intersect, so compass should show two directions. It is not possible. Understood? So that's enough. That is about magnetic field lines and magnetic field. So now we will discuss about so I am taking the straight conductor. This is the straight copper conductor. Okay, current is passing. So now you can see this is the straight conductor. Current is passing. So if you place, so here I am placing the cardboard. So to place the compass, so I am placing the compass over here. Okay, so compass. This is north and south, east and west. North and south, east and west. Current is moving so north to south. Okay. So by using right hand thumb rule, we can identify the magnetic field around the current carrying conductor. So here you can see the current is passing, right? Current is passing from north to south. So around the straight conductor, so magnetic field will be created. Just now we learned about magnetic field around the bar magnet. So magnetic field will be there when the current is passing. That is electromagnet. When the current is passing through the conductor, so it behaves as it produces magnetic field. Okay. So here if the current is passing through the conductor, magnetic field will be produced. Around the conductor, magnetic field will be there. So in which direction the magnetic field will be? So the magnetic field will be in the form of closed loops like this. So current is moving from north to south. The magnetic field will be So in this direction, okay, so you can observe, and the compass will be showing deflection towards east. Compass will show deflection towards east if the current is passing from north to south. If the current is passing from south to north, the deflection will be shown towards west direction, towards west direction. So by using right hand thumb rule, if the current is passing upward direction, the magnetic field will be like this. Okay, so if you think current is passing towards you, so magnetic field will be anti-clockwise direction. If the current is passing towards a board, so magnetic field direction will be in the clockwise direction. So if current is passing towards you, magnetic field direction will be anti-clockwise direction. If the current is passing towards the board, magnetic field will be clockwise direction. Okay, so if the current is passing from north to south, so magnetic field will be like this. If the current is passing downward direction, so magnetic field will be. Okay, so you have to place along the current direction, you have to place the thumb. Along the current direction, you have to place the thumb. Folding fingers, curly fingers, wrapping fingers. Folding fingers, curly fingers, wrapping fingers represent magnetic field. Okay, so that is a magnetic field. That is the magnetic field. I hope it is very clear. That is that. So that is the magnetic field, the direction, magnetic field direction. So here you can observe, and one more point, if the current is passing like this, so around the conductor magnetic field will be produced. Around the conductor magnetic field will be produced in the form of concentric circles. In the form of concentric circles are nothing but closed loops. Concentric circles are nothing but closed loops. So like this it will go. So like this and like this. Understood or not? Like this. So the magnetic field will be in the form of concentric circles. Magnetic field will be in the form of concentric circles. Near to the conductor, more magnetic field will be there. Near to the current carrying conductor. Near to the current carrying conductor, more magnetic field will be there. So if you move away from the current carrying conductor, less magnetic field will be there. So magnetic field is directly proportional to current passing through the conductor. Magnetic field is directly proportional to current passing through the conductor. Understood or not? Okay, so more crowding of magnetic field represents more magnetic field. More crowding of magnetic field represents more magnetic field. Understood or not? So near to the conductor, more magnetic field will be there. Away from the conductor, less magnetic field will be there. So magnetic field is directly proportional to current passing through the conductor. So by using right hand thumb rule, we can identify the magnetic field direction around the current carrying conductor. And one more thing, if you change the battery direction, automatically magnetic field direction also changes. If you change the battery direction, means current direction. So if you change the battery, like a positive terminal here, negative terminal that side, if you change the current direction, here current direction is very important. If you change the current direction, automatically magnetic field direction also changes. Okay, magnetic field direction also changes. Very, very important. And one more thing, by using right hand thumb rule, we can identify the magnetic field direction around the current carrying conductor. And one more thing, here if you send the current only, the conductor will behave as a magnet. So if you remove the current, if you remove the battery, so conductor does not act as magnet, or it does not behave as a magnet. So it does not produce any magnetic field. Okay, so it is a temporary magnet. So whenever you connect the battery, it acts as a magnet. Whenever you remove the battery, it does not act current. So until the current is passing through the conductor, it acts as or behaves as a magnet. If once you stop sending the current through the conductor, so it doesn't act, it doesn't behave, it doesn't produce magnetic field. I hope it is very clear. Understood? Yes. So these are the points now. So we'll discuss about loop. So I'm taking the loop. So this is the loop. This is the loop. So here positive terminal, negative terminal. Current is passing. Current is passing. So here turn, 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 turn. Dun, 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 dun. So here you can observe. So when keep on magnetic field is changing at this center. So here you can observe 1, 2, 3, 2, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. Dun, 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 dun. Dun, dun, dun. Okay, so I hope it is very clear. This side is north and this side is south. This side is south. Understood? Current is passing like this. So where the magnetic field will be more, at the center or circumstance? Where the magnetic field will be more? So at the center itself, because when the current is, so you can observe here. So when keep on magnetic field is moving, at the center it will become parallel lines. Okay, one magnetic field will be added to another. This magnetic field will be added to this one. This magnetic field will be added to this one. So that's why uniform magnetic field will be there. So at the center, so more magnetic field will be there than at the circumstance. At the center, more magnetic field will be there. Okay, so this is the loop. Okay, next one. Solenoid. Yeah. So now we are discussing about solenoid. Solenoid is nothing but taking a straight wire, wrap in the shape of cylindrical shape, take a straight wire, wrap in the form of cylindrical shape, take a straight wire, wrap in the form of cylindrical shape, that to connect to the battery. So then current is passing through the wire, it acts as a magnet. Yes, so you can see I'm taking this one. So like this I'm connecting. So here you can see battery. So here positive term, negative term, current is passing. Okay, then you can observe here 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so then it will be connected 1, next one 2, next one 3, next one here 1, next one 2, next one 3. So then here 3, 1, 2, 3. 1, 2, 3. Understood? Current is passing to the point at the same time. So magnetic field also should reach to this point. Then we can say this is south. This is south. This one is south. Okay, so this one is moving away. This is north. Okay, so okay, so now you can observe here. This side is south, this side is north. Current is passing and here also current is leaving. Here you can take, so same you have to compare with the magnetic field of bar magnet. Here you need to understand one thing. solenoid act as a bar magnet. Okay, so when you suspend the solenoid, always it shows north and south direction. Magnet produce magnetic field. And here one thing, so here you can observe, so for bar magnet, magnetic field is fixed, but solenoid magnetic field is not fixed. Okay, for bar magnet, magnetic field is fixed. For solenoid, magnetic field is not fixed. So we can change the magnetic field. So we can increase the magnetic field by sending more current. So strength of current is increasing, automatically magnetic field also increases. And the number of turns if you increases, automatically magnetic field also increases. But here coming to the bar magnet, we can't improve the magnetic field. We can't increase the magnetic field. It is fixed. It is fixed. And one more thing, we can change the poles of the solenoid. For bar magnet, so those poles are fixed, north pole and south pole. But coming to the solenoid, so poles, we can change the poles. How can we change the poles? By changing the battery, or by changing the battery polarities. Okay, or by changing current direction, automatically poles can be interchanged. Understood? So here we can change the magnetic field. We can change in a sense, increase or decrease. We can increase or decrease the magnetic field. For bar magnet, we can't change. Okay, we can't increase, we can't decrease the magnetic field. Here, so poles also we can change. Okay, poles we can change. But here poles are fixed. That's enough. So here magnetic field will be produced. Here also magnetic field will be produced. Understood or not? So this is about solenoid and bar magnet. So differences. Next one we will discuss about one more. That is so you can take a current carrying conductor placed in the external magnetic field. A current carrying conductor placed in the external magnetic field experience the force. So I am taking this one. So this okay. So here I am considering like this. Dun, 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 dun. So here you can observe. Then I am taking the stand here. I am considering stand over here. Stand. Okay. So those are new to the channel. So do like, share and subscribe to Student the Brand. So inform your friends, ask your friends to join to the class. Spread a word regarding the channel. Inform to everyone. Just if the content is good. So if explanation is good. So you can do like, share and subscribe to Student the Brand. So inform to your friends, ask your friends to join to the class. So ask them to subscribe, the content is good. So north and south. So current is passing like this. So next, so you can see this is a battery. Positive terminal, negative terminal, current is passing like this. Okay, so current is passing. A current carrying conductor placed in the external magnetic field experience the force. A current carrying conductor placed in the external magnetic field experience the force. By using Fleming's left-hand rule, so we can identify the direction. Okay, so you can see. So this is south. Okay. By using Fleming's left-hand rule, we can identify the direction of the force acting on the conductor. So index finger represents the magnetic field. Index finger represents the magnetic field. Middle finger represents the current, and thumb finger represents the force. So you can observe. So magnetic field, current is passing in the conductor. So like this, in the conductor. Then if you show the thumb, in which direction the thumb is showing? Into the board. Into the board. Understood? Into the board. So the force acting on the conductor will be into the board. Into the board. Understood, Anna? So by using Fleming left hand rule, we can identify the force acting on the conductor. Force acting on the conductor. I hope it is very clear. I hope it is very clear. Understood? And coming to the next one, a short circuit. So the direct contact of live wire and neutral wire takes place and heavy amount of current will be drawn from the mains. And the next one, coming to the overloading, high voltage appliances on at a time. The high voltage appliances on at a time, then heavy amount of current will be drawn from the mains. Understood? So that's enough. And coming to the next one, so that is live wire. Live wire potential is 220 volts, red in color. So second one is neutral wire. So neutral wire is 0 volts, black in color. And coming to the third one, earth wire. So 0 volts, green color. Understood? Green color. So red color, black color wire, and coming to the green color wire. Understood? So the potential difference between live wire and earth wire is live wire and neutral wire is 220 potential. So live wire and earth wire also put 220 potential difference. But the difference, the potential difference between neutral wire and earth wire is 0 volts. Very important. Very important. Okay. Potential of live wire is 220. Potential of neutral wire is 0. Potential of earth wire is 0. But potential difference between live wire and earth wire, live wire and neutral wire is 220 volts. Live wire and neutral wire is 220 volts. So very important. So MCQ's point of view, very important. Make sure that you are learning all these points. Live wire, neutral wire and earth wire. Clear? Okay. So I hope it is very clear. So we discussed all the points. So I hope. So if you like the content, if you like the channel, if you like my explanation, please do like, share and subscribe to Student the Brand. So check the video. So go and check the content. So share to all your friends. Ask your friends to join to the class. So I'll be taking live classes. So live classes will be there. So I hope this is the 6th class what I am taking. So 6th class. So this is class number 6. Okay. So I took 6 classes based on CBSE grade 10 physics. All are I'm uploading. So target physics 25/25. So in that playlist I'm uploading all these videos. Okay, so check all the videos and I'm uploading the shorts also, which I'm not able to cover in the live class. So I'll be uploading like a shorts. So check those videos also. Very important, high important questions and very important for the exam point of view. Those questions I'm preparing like a short. So just check those videos and share to your friends. Ask your friends to join to the live classes. So do like, share and subscribe to Student the Brand. Thank you so much. So for your attendance and inform to everyone. So please spread one word regarding the channel. So we are doing so much hard work. So make this content to reach to everyone. So check the content once. So all are experimental content only with proper physics content. The two CBSE textbook related content I am taking. So based on that one I am doing all these things. So please do like, share and subscribe and support the channel. Share one word regarding the channel to everyone. Okay. So thank you so much for supporting. Thank you so much for your support. So this is our Shiva sir from Student the Brand. Thank you so much. We'll see you in the next live class. Thank you all.